But just a little background about what these things are. A linear inequality is just like a linear equation, you know, in two variables, x's and y's, except it uses inequality symbols. We've done some stuff with this already, right? If you go back to chapter 1, we did some algebra with inequalities. This is much easier. Okay, there's a bunch of ways that these could look. You know, they could look like that, or they could look like that, or there's all these different inequality signs we could get. An ordered pair, x and y, is a solution of the linear inequality if it makes it true. That's what solutions do, right? So for example, if we have the linear inequality y is greater than or equal to 3x minus 9, well, we could see if this ordered pair is a solution by just checking it, plugging in those x and y values and seeing if they work. If I plug -6 in for x and 2 in for y, I just get this, right? 2 is greater than or equal to 3 times -6 minus 9. Well, what's that work out to be? Was it? Oops. Did I go too fast here? Okay, so it is a true statement, and that was the end of it. It is a true statement, isn't it? Because I end up with -18 minus 9 is -27. Is 2 greater than or equal to -27? Yeah, so it is. That's true then. So this is an example of a solution of this linear inequality, right? So if we want to check whether the ordered pair 0, 1 works, you know, we plug it in, substitute, and we get the answer 2 times 0 plus 3 times 1 is 3, and that is not greater than or equal to 5, right? So it's not true. It's not a solution. If I check 4, -1, though, I get 5 back. Is 5 greater than or equal to 5? Yeah, it's equal. So that is a solution, right? And so obviously we could just keep testing things, but there's got to be a better way to do it, right? And that's what we're going to look for. Is there a better way to do this? Okay, so let's see what happens here. If we take the linear inequality x plus y is greater than or equal to 1. If it's a solution, we'll color it blue. If it's not a solution, we'll color it red. And let's see if we can see if there's a pattern, something going on here. So if we try these things, 2, 2. Well, if we plug 2, 2 in, it's not a solution. If we plug 1, 1 in, it was a solution. 2, 2 was a solution. 2, 1 is a solution. If I just plug these in, right? -1, -1 doesn't work. I end up with -2 is greater than or equal to 1, false. So that's red. If I keep plugging in points, I'm starting to see a pattern, aren't I? Right? Look what happens if I graph the line x plus y equals 1. And what's our trick for that? If this is in standard form and I want to graph this thing, what's my trick for finding the 2 points? I could put it in y-intercept form. That works. That definitely works. I could do that. There's the other trick. Remember that cover-up trick I showed you? If it's written in standard form like this? I could check. Good. Plug in zeros. Okay, Evan, what do I do? Okay, good. So if I let x equals 0 to find the y-intercept, I get y equals 1. If I let y equals 0 to find the x-intercept, I get x equals 1. So my intercepts are at 1, 1, right? Connect and extend. Well, there's the line x plus y equals 1. What do you notice about this pattern?
All the solutions are.
Yeah, all the solutions are on one side of that line. In fact, that line is the boundary between all of the infinite solutions up here and all of the infinite non-solutions down here, right? That's the way it's always going to be. If you graph a linear inequality, there's always going to be a boundary line and then a half plane with all of the solutions and a half plane with all of the losers, the non-solutions. Okay? Always looks that way. So then all we have to do, if we want to graph something, graph a linear inequality, the solution, is we just have to graph the boundary line and then just test to see which side the solutions are on. Test one point. If it works, then it's on the side with all the other solutions. If it doesn't work, it's on the wrong side. So I shade the other side because that's where all the solutions are. That's it. Okay, so graph the boundary line. Now, here's one important thing about that. If the inequality includes an equal sign, then the boundary line is part of the solutions, right? And so I would graph it as a solid line. If the inequality doesn't include an equal sign, if it's either less than or greater than, then it's only a boundary line, so it's got to be dashed. Points on that line are not included in the solutions. It's just the boundary. So dashed if it's without an equal sign, solid if it's with an equal sign. And then to decide which side to shade, I just test a point, a convenient point. Okay? So let's look at a couple quick examples. So if we look at the graph, let's take some real easy ones, horizontal and vertical ones. If y is less than -2, well, that means the boundary line is the line y equals -2. What does that look like? Is it up and down, or is it horizontal or vertical? It can be horizontal. Good. We know that whenever we get y equals a number, a constant, or x equals a constant, those are the oddball ones. Those are horizontal and vertical. And because it's y equals, that tells us that the y-intercept is -2, so it's got to be horizontal, doesn't it? Right, so here's our boundary line. Now, is it going to be solid or dashed? Dashed, because it doesn't include an equal sign. Good, so there's our dashed boundary line. We want to just test a point to see which side gets shaded. Now, here's a great hint. As long as the boundary line doesn't go through the origin, so in other words, if the origin is not on the line, test 0, 0. That's the easiest point to test. Plug in 0 for x and 0 for y. Well, there is no x in this case, so all I have to do is plug in 0 for y. If I plug 0 in for y, I get the result that 0 is less than -2. Is that true? False. So then do I shade the side with the test point?
No.
No, I shade away from it because it's a loser, right? So I shade down below. That's my solution, right?
How are you gonna do that in Moodle?
Well, in Moodle, you do the same thing you did with the other graphs. I'll give you choices, and you choose the right one, okay? So what about this one? X is less than or equal to 1. That's going to give us a boundary line of x equals 1. So is that vertical or horizontal? Vertical. Is it going to be solid or dashed?
Solid.
Solid. Good, because it includes the equal sign. So we got a solid boundary line at x equals 1, and then we'll just test the point 0, 0, because it's off of the line. If I plug in 0 for x, I get 0 is less than or equal to 1. True or false? True. So I'll shade that side, okay, with the test point. Let's try one more that's got a slanted one. How about how about this first one? Y is less than 2x. I graph the boundary line, y equals 2x. So that's in y-intercept form, right? What's the slope? What's the y-intercept? So what's that mean it is? No. If the y-intercept isn't there, it must be equal to what? 0. Yeah, right? Because that's the only reason we wouldn't say 2x plus 0. We just don't write the plus 0, so it must be 0. So this is a line with a y-intercept of 0, so it's going through the origin, and it's got a slope of 2, so I can rise by 2 and run by 1 to get a second point. There's my boundary line, right? And now let's test a point, but this time notice that the line goes through the origin, so I can't test the point 0, 0. I have to test a different one. They chose to test 1, 1. That's fine. We can do that. I would have picked something that's more obviously, something like maybe 0, 3 or something. Something that's really obviously not on that.
Well, they're probably not as smart as you, so.
I think they're probably smarter, but 1, 1 that's just cutting it a little bit close to me, but it's all right. So if I plug in 1 for x and 1 for y into my original inequality, what do I get? Let's see. I'd get 1 is less than 2 times 1. Is that true? That is. So then the test point passed, so we'll shade to the right then, right? That's it. Make sense? Okay. Now, how do you do this on a calculator? There's a great way. Let me show you the trick. Here's the great trick. So get out your calculators. If you need one, grab one. I got 6 of them.
Nice. See, I think I don't know Spanish, Medina.
Yeah, it's an Asian middle name.
How about a song like just like Alex Martinez says.
Just That's a boring color.
Go orange.
Yeah.
Okay. So, if you want to do this on the calculator, there's a program on there called, it's either called Inequal or Inequal Z. And it's one or the other. I'm not even sure which one it is. Let me get rid of this. Is it Inequal Z? It's going to be one or the other. It's either going to say Inequal or Inequal Z. Both of them do the same thing. So if you go down, if you're in the applications, if I just hit alpha, you want to see that little alpha tag up there? Actually, no, I don't think I can. Yeah, I can. If I hit alpha and then I, it'll skip down, and mine's called Inequal Z. Does everybody have that? Raise your hand if you don't have it. Oh, wow, everybody's got it. First time ever. That's great. Okay, so then if I just click on Inequal Z, there's a couple little things you got to know about on this. It says press any key. Look what it does. It does a couple things that are really cool here. It, first of all, if the cursor is over the equal sign, all these different options pop up at the bottom of the screen. Now I access those with the F1, F2, F3, F4, F5 key, but I've got it in this program. In order to activate those keys, I have to push alpha, right? So, yes, ma'am.
Mine says conflicting apps and gives me two options since we quit inequality quit apps.
So in other words, you must have another one on that's conflicting. So let's see. Yeah, that's your key. Press any key. With alpha, a little stretch. Yeah. Yeah. Now. No. We need to tell it. There we go. See? Yeah, that transform one. I don't know how that gets turned on, but that one's, I hate that one. It always screws everything up. Okay, so anyway, here's what you do. So if I want to put in an inequality, like let's say I want to put in the inequality, how about y is greater than or equal to 2x plus 1. Okay, so I'm going to hit the alpha key. Oops. I'm going to hit the alpha key. And then notice that turns into a flashing A. And then I'm going to choose this key right here, right, for less than or equal to. Oh, I want greater than or equal to. That one. You can do it again. You can just override it. Okay, and then I'll scoot over and just like normal, I'll put in 2x plus 1. Now watch what this does. If I go zoom 6, check that out. Look what it does.
Whoa.
Whoa, how'd you
What's
get
that?
Thing? Cool. Push grab?
Yeah, you hit zoom 6, so it sets your window up. Zoom standard. So it sets your,
Have the little graph.
Yeah.
It just has the shape.
oh, okay. Here, I can fix this. Here's got.
Pretty cool.
Yeah.
The sign's gonna take 2 seconds.
What?
The sign's gonna take 2 seconds before you get that. You have to put it on the stuff.
Okay.
Too. You have to know how to do it.
We good? Now let me show you a trick here. So, everybody get that?
Yeah.
Okay. Now, if we want to identify that line, we can identify it by looking on the graph, but we could also, if we want to, if I want to identify some key points, I can still do all that tricky stuff I did when I normally graphed a line. I could go, for example, is everybody listening? I don't think so. Listen. If I want to find the y value at, say, x equals 3, so I can identify a point, I can just go trace 3, enter, and look what it does. It puts the cursor there and it tells me what the ordered pair is.
Whoa.
So that's pretty good. I can go find it. Once I get it graphed, I can identify that graph pretty easily by just finding a few key points on it. The other way of doing that, remember, is I can always go second, calc menu, and then value, and then type in the x value. But it's quicker just to go trace and then type in the x value. That's our shortcut.
That didn't work for me.
Which one didn't?
I pressed trace and 3 and it didn't do anything.
You push enter.
I did. What? No.
You have to be, okay, let's see. Yeah, if I hit graph. I'll do something else on that. Yeah, I think it's because you have a clock. Yeah. Okay, that was a problem. I'm sure that was it. Yeah, in order to use that, you want to, if you're going to do the trace method, you can only have one graph working at a time. So if there are any plots that are wrong, you have to turn them off and unhighlight. Otherwise, you have to use the long way.
Yeah, Medina. Well, what's second count?
Because your plots are wrong. So you just go
What
Y
else,
equals, and then you go up, highlight plot 1.
Where's the calc at?
and enter it, turns it off. So now if you
The
graph
zero?
you see that one. Okay?
Or is it the second graph? Or second trace?
Yeah, it's second trace to get to the calc menu. Okay, so that's handy. Now here's another thing this does for you that's really cool. Okay, go back to Y equals. Let's clear this one out. And now watch this. If I go up to the X equals button up there, and I hit enter, look what it does. This gives me the option, which the normal grapher doesn't have. It gives me the option of graphing vertical lines. And you normally can't do that on a TI-84. So if I want to graph the vertical line, let's say X equals 4, for example. It graphs it. Okay? I can also do inequalities there. If I want to graph instead, how about if I go up to X equals and hit enter? What if I want to graph X is less than 4? Oops, I gotta hit, what did I do? I forgot to push alpha, didn't I? So alpha less than, or I did greater, oh, hang on. I forgot to go up to X equals. Notice that the X equals is highlighted now. What's that telling me? That I've got something in there, right? I've graphed something in there. Because when I hit Y equals, it's always going to default to the Y stuff. So if I go up to X equals and hit enter, there's my X equals 4. Now it's also important that when you're done graphing that, the X stuff, you delete it. Because you won't see it when you go to Y equals. The X will be highlighted, but it'll be kind of in the background, you might forget. So when you're done, delete them. Alpha less than, so now I've got X is less than 4. If I hit graph, look what it does. Notice it even gives me a dashed line for my boundary. How about that? Okay. So here's the other issue that comes up with this, is what do you do if they give you, and I'm going to show you a great little trick for this. You're going to love this. Okay, what if you have a linear inequality you want to graph that's not solved for y? What if you have something like 2x minus 3y is greater than 7? Okay. You got to put it in y equals, or y, isolate the y, right?
Yeah.
But we can do this, right? We can solve this right into our calculator. This is a great hint. Watch this now. So if we go back to y equals, let's go up to the x equals stuff and clear that out, because we're not using it anymore. So go to the x equals menu, clear that guy out. And now if I just hit y equals, it takes me back to the normal one. Now if I'm going to isolate y, what are the steps I'm going to go through to do that? First I'm going to subtract 2x, and then,
Divide by negative.
okay, good. So here's how we do this then. We're always going to start off over here. We're going to open a set of parentheses for the numerator. So open a set of parentheses, and we start off with what's already on this side, right, which is the 7. The 7 is already on the right side in the top of what's going to end up being a fraction, right? So I put the 7 there. Now, to get the y by itself, I'm going to subtract 2x over to the other side. So I'll just do minus 2x. Close the parentheses, because that's the whole numerator, right? And so that gets me up to here.
Divided by.
Divided by, exactly. So I'm going to end up with minus 3y is greater than 7 minus 2x. And then the last step is to,
Divided by negative.
good, divide by negative 3.
Did
So
you
I'm
have to
gonna-
change the sign, or do you have to change?
You do, exactly, which is why you have to do that. So we'll go divided by negative 3. And that means I've got to flip the sign, doesn't it? So I'll go back and I know that that sign is going to turn into a less than. And so I don't have to do any of this on paper. I can just go back over here and hit alpha. And make that a less than. And I got it, right? I just solved it into my calculator. So if I go zoom 6,
That's snazzy.
there it is.
Yeah.
Okay? pretty slick. So if you start like this, just, I mean, it's a great way to do it. If you just open that set of parentheses right away, and I think to me, this is something like when you're taking SATs or you're taking college entrance exams, this is a great trick. Yep.
Yeah, mine's over.
Doesn't look like that? Did you hit Zoom 6?
Yeah, it's different. It's upside down.
Oh, okay, that's because your sign's backwards. Or yours or mine is. Maybe I screwed
I
up.
think yours is.
Wasn't it supposed to be, we gotta flip it to a less than. No, yours is greater than. Okay, so that's the difference. Okay, now notice we get a dash line because it doesn't include an equal sign. How about that? We good?
Isn't less than to the left?
Less than points to the left.
So how come I did that and then I got mine opposite?
Is mine backwards? No, that's a less than sign right there.
See, not only
Wait, where, how about the thing?
Alpha.
Yeah, and then that's less than, right?
Well, it's so dark you can't see it. Right. Less than it should go like that.
Yeah, that's what mine is.
Uh-huh.
And then zoom 6.
Uh-huh.
Where's yours go? Just go up or down?
It's like that.
Yeah, mine's opposite.
Okay, you must have maybe forgot the negative sign.